Welcome. In this video, we are going to see about the particulate nature of matter, that is the first unit of Igcse Cie chemistry. This is the syllabus of first unit of Igcse Cie chemistry. First chapter, Kinetic Theory. As we know already, there are three states of matter. They are solid, liquid and gas. First, we will see the properties of solids. Solids have strong intermolecular force of attraction between its particles. Due to that, the molecular arrangement is in regular pattern. In this picture, you can see that the particles are stick together with each other and are in a regular pattern. If thermal energy, that means if solids are heated, the particles cannot move or they can vibrate in their position itself. This is also due to strong intermolecular forces. Solids have fixed volume, shape and high density. Next, the properties of liquids. Liquids have weaker intermolecular forces of attraction than solids. On account of that, the molecular arrangement is random. Because of weaker intermolecular forces of attraction, particles can move and slide on each other. Due to this property, liquid can adopt the shape of any containers and also liquids are able to flow. Liquids have fixed volume but don't have fixed shape. For example, if you pour 1 liter of water in a jar and in a pot, both of them have same volume of water, but the shape of the water depends on the shape of the container. Liquids have a moderate to high density. Next, properties of gases. Gases have no intermolecular forces of attraction between their particles. Due to that, particles are far apart and move quickly in all directions. Gas particles collide with each other and with the sides of the container. Because of the collisions, pressure will be created inside the container. Gases have no fixed volume and shape. Gases can be compressed. For example, in our houses, the LPG, liquefied petroleum gas, which is used as a fuel for cooking, is actually a gas, but inside the cylinder it is in the form of liquid because of the gas is compressed into liquid. Gases have very low density. This is the overall comparison of the properties of three states of matter. Next chapter, states of matter. In this chapter, we are going to see the interconversions of the states of matter, of which first one that we are going to see is melting. Melting is nothing but it's the interconversion of solid to liquid. When a solid is heated, the heat energy will be transformed into kinetic energy, which allows the particles to move. During the properties of matter, we have seen that in solid, particles cannot move, but in liquid they can. So this kinetic energy will break the intermolecular force of attraction and allow particles to move. So solid will be converted into liquid. And melting occurs at a particular temperature, and that temperature is called as melting point of a solid. And melting point is unique to each pure solid. Next interconversion is boiling. During boiling, liquid will be converted into gas. As melting, during boiling also the heat energy will be transferred into kinetic energy, and it will break the intermolecular forces of attraction between the liquid particles and allows them to move far apart from each other. Boiling also occurs at a particular temperature, and that temperature is called as boiling point. Boiling point is unique to each pure liquid. If a liquid is impure and due to the impurity, boiling point will be varied. For example, pure water boils at 100 degrees Celsius, but if you add sugar or salt with the water, then the boiling will not occur at 100 degrees Celsius. If you have thermometer at home, you can check. Next interconversion is freezing. It is the interconversion of solid to liquid. Liquid to solid. It is the reverse process of melting, and both melting and freezing occur at the same temperature. For example, ice cubes melt at 0 degrees Celsius as well as water freezes at 0 degrees Celsius only. And freezing point also unique to each pure liquid. Next interconversion is evaporation. It's also like boiling interconversion of liquid to gas only. But the difference between boiling and evaporation is boiling occurs throughout the liquid and the evaporation occurs only at the surface of the liquid. And also the another difference is evaporation can occur even below the boiling point. I hope all of us have seen the evaporation on the roads usually. On the roads there is no any source of heat, though it's happening because evaporation can occur over a range of temperatures. In large areas and warmer conditions, for example in seas and oceans, evaporation will be faster. Next interconversion is condensation. It is the interconversion of gas to liquid. Melting, boiling and evaporation are a heating process, whereas condensation is a cooling process. I told you that in the previous cases, during heating, thermal energy will be transformed into kinetic energy, and that energy will break the intermolecular force of attraction. But in the case of condensation, while cooling, particles lose their kinetic energy, which is the main reason for particles movement, and particles group into a liquid. For example, if you boil water in a closed vessel and you allow cooling the water in the vessel itself, after some time you can see some water droplets in the vessel lid. It happens because of the condensation of steam. During boiling, water particles converted into steam, that is gas, because of heat energy. During cooling, steam particles lose their energy and group into liquid. For condensation, no energy is required and it occurs by itself. Like evaporation, condensation also occurs over a range of temperatures. Next interconversion is sublimation, and it's quite different from rest of the interconversions. It's a direct interconversion of solid to gas. This special type of interconversion is possible only for few solids. For example, iodine and solid carbon dioxide. Even camphor and bathroom air fresheners like odonil are also examples for sublimation. If you keep odonil in the beginning of the month in your bathroom, at the end of the month that solid will be vanished. Because of sublimation, that white color solid will be converted into gas directly. And the reverse process is called de-sublimation or deposition. Next chapter is heating curve. In this chapter, first we are gonna see Brownian motion. It is the process of jerky and erratic motion of smoke particles. In 1905, Albert Einstein explained the movement of pollen grains in water by individual water molecules. Random movement of particles in a liquid or gas produced by large number of collisions with smaller, often invisible particles. In solid, particles cannot move, so it is possible only for liquids and gases, not for solids. See this image. The larger green color particle is randomly moving because of the collisions of blue color smaller particles. This is called Brownian motion. Next topic is diffusion. Diffusion is nothing but the process of different gas or liquid mix and is due to random motion of their particles, that is called Brownian motion. Particles move from an area of high concentration to low, and diffusion will take place till even concentration of all the space. For diffusion, no energy is needed. See this video. See, I'm going to mix potassium permanganate in water. I'm not going to mix, which means I'm not going to give any external energy to it. But see the difference. See, liquids, see this, the different mixtures mixed together, and they are mixing by themselves without any external energy, and the process is happening till the same concentration of all this space. Diffusion is faster in gases than liquids because gas particles can move faster than liquid particles due to no intermolecular forces between the gas particles. Diffusion rate is different for each gas and liquid. In same temperature and same condition, if you try to mix different gas of liquid, diffusion rate will be different. Based on the relative molar mass, rate of diffusion will be differing. For smaller molecules, diffusion rate will be higher, and bigger molecules, diffusion rate will be smaller because smaller molecules can move faster than the bigger molecules. Next, I am going to conduct a reaction between ammonia and hydrochloric acid. In right hand side, aqueous HCl is dipped in cotton and it's kept. In the left hand side, aqueous ammonia is dipped in cotton and it's going to be it's kept. The tube is closed now. Reaction is taking place between the acid and base, that is between ammonia and hydrochloric acid. See, after some time there is a ring formation near to HCl end. This is because of the molar mass of hydrochloric acid and ammonia. The molar mass of HCl is 36.5 and of ammonia is 17. Because of the less molar mass, ammonia can move faster than hydrochloric acid, and higher molar mass HCl is not moving from the cotton. On account of that, the product, that is ammonium chloride, is formed near to the HCl end. So based on the relative molar mass, rate of diffusion will be differing. Last topic in this chapter is changes in state and kinetic theory. When substances are heated, the particles absorb thermal energy which is converted into kinetic energy, that is the energy of movement. While heating, the particles in solid will start vibrating and expand until the structure breaks. Then the solid melts to liquid. In liquid state, particles can move and slide. On further heating, liquid particles expands more and some particles at the surface gain sufficient energy to overcome the intermolecular forces and evaporate. I told you already that evaporation occurs over a range of temperatures and only on the surface of the liquid. When the boiling point temperature is reached, all the particles gain enough energy to escape and the liquid boils. These changes in state can be shown on a graph which is called a heating curve. Cooling down a gas has the reverse effect, and this would be called a cooling curve. These curves are used to show how changes in temperature affect changes of state. See this image. This is the heating curve of water. From minus 40 degrees Celsius to 0 degrees Celsius, which means till the melting point of water, water particles will be in the solid state, which means water will be in the form of ice. Once the temperature melting point is reached, water will be in both the forms of liquid and solid because both melting as well as freezing points are same. While temperature is increasing, which means after 0 degrees Celsius, water will be in the form of liquid alone. As I told you already, evaporation can occur over a range of temperatures. So, till 100 degrees Celsius, at the surface, evaporation will be taking place. Once the boiling point, which means 100 degrees Celsius, is reached, water will be in both gas and liquid states because boiling as well as condensation temperature both are same, which means both are 100 degrees Celsius. So in that temperature, water will be in both gas and liquid state. After 100 degrees Celsius, water will be in the form of steam, which means water will be in the form of gas alone. This is the heating curve of water, and from this you can understand, I think. Thank you for watching videos. Please subscribe, like and comment. Thank you friends.